All right, here we go. This is your review for the quiz you took yesterday. It's test two, or sorry, test five, quiz two. Um, Up here at the top are the scores from the other classes. Second period was an 81.4. Third block was a 72.8, and fourth block was a 74.2. And without further ado, our test quiz average was, oh no, 78.5. And we did not win this one. So make sure you're taking good notes on the questions that you missed. Make sure you know what you did wrong, what you did right, so that you can prepare for the next quiz and the midterm next week on Wednesday. So here we go. Number one, we didn't do so hot on. It's 46% right. So I'm going to pull up Desmos so you guys can see the calculator while I do these, since I'm not here with you and checking to make sure you're punching it on the calculator. So let's pull Desmos up. Let's read this thing, and here we go. Jeremy and Ashley are comparing their investment accounts. Jeremy was offered a savings account that earns 7% interest rate. That means my rate is 7%, and 7% as a decimal is 0.07. And the interest is compounded annually. Annually and compounded mean how many times is it happening per year, which gives me my end value, and annually means it's happening one time per year. So my end value is one. And Ashley was offered a savings account. I'll say that was Jeremy. Cool. We'll do him in blue. And then Ashley was offered a savings account that earns 6% interest rate. So Ashley will do in red, and that means her rate is 6%. Which as a number is 0.06, and it is compounded weekly, which means how many weeks in there are there in a year, and there are 52 weeks in a year. That means my end value for Ashley is going to be 52. And then the question says if they both invest $10,000, that means both of them's initial principal that they put in, we'll do it in black, is going to be $10,000. They want to know who has a higher balance after a time of 8 years. So what you need to remember with this information is that our compound interest formula looks like I can find the amount of money that's going to be in the bank by taking the principal and multiplying it by 1 plus the rate divided by the number of times it's compounded, all raised to the power of the number of times it's compounded by the amount of time that you're going to do it. So we'll do Jeremy in blue. That means Jeremy, he invests $10,000. That was our initial principal. It's going to be 1 plus Jeremy's rate, which was 0.07. And Jeremy's was compounded one time per year, so his end value is 1. That means up in the top in the exponent, I got to do 1 times the amount of time, which was 8. And we type that into Desmos or into our calculator, 10,000. And then in parentheses, 1 plus, and then 0.07 over 1. And then that whole thing's got to be raised to the power of 1 times 8. So Jeremy would make $17,181.86. That's how much he'd have in the bank after 8 years. We'll do the exact same thing for Ashley. Hers sets up the exact same way, $10,000 in the bank. 1 plus her rate was 0.06, but she's compounded 52 times per year. So then I got 52 underneath the fraction and 52 times 8 in the exponent. Let's see, 10,000, and then 1 plus 0.06 over 52. And then we've got to raise this whole thing to the power of 52 times per 8 years. And Ashley, although is probably doing really well with the compounding, she's only going to have $16,156.27 after 10 years. So if it says who would have the higher balance and how much would it be, how much higher would it be than the other person? Well, Jeremy has the higher balance, right? And if you subtract their two balances, you can see the difference in those two. So 17,181.86 minus 16,156. 156.27, and the difference in their two balances is $1,025.59. So long problem, but It's just a matter of making sure that you write the equations out carefully, and then answer the question at the end. Who has the higher balance? That's Jeremy. And then how much higher is it, or how much more did he make? Sweet. Number 2 on Clayton's test here, quiz here. Find the equation of the exponential function represented by the table below. Well, since it says exponential function, I should know exactly what's happening each time. All right, we talked about how linear was the same as arithmetic, right? Which meant I added the same number every time. That's a constant rate of change, which is adding or slope. And exponential goes along with geometric sequences, which was multiplying the same amount every time. So you can treat exponential functions just like you treat geometric sequences, and you can see as my x value increases by 1, you're going to see the x value increasing by 1. What did I multiply this by to get from one number to the other? And the way you can tell that is by literally taking the second term and dividing by the first term. So 1.5 divided by 3, and continue that. 0.75 divided by 2, or sorry, 0.75 divided by 1.5, almost went across. You got to go to the one right before it. And then 0.375 divided by 0.75. And all of these things should give you an exact, well, common ratio, or really what we're talking about here is the base, the multiplier, the thing that we're multiplying by. And it should look like 1.5 divided by 3, which is 1/2. If you type in the other ones, you should get the exact same thing. 0.75 divided by 1.5, 1/2. 0.37375 divided by 0.75, 1/2. Now, if you're not sure about that, there's a little button over there to the left of it. Looks like the little fraction button on the calculator. If you click that button, it'll turn it into a fraction. So my base is 1/2, which means in my equation, I should have a decay base of 1/2. And if I look over here, let's see, this one right here has a slope, which means it is linear and is no good. The only ones that we're talking about that are exponential are the ones with x's in the exponents. And if I look very carefully at these, the base of this exponent is 3. That means it is growth and it is going up. The base of this one is 2. That means it is growth. It's greater than 1. It is going up. And it's clear that these numbers are going down. So the only one that it could possibly be here is decay. We found the base is 1/2. And if you really want to get crazy with it, the initial value is always your starting amount. And look, the initial value there happens to be 3, and that's what goes where the a value is 3. So answer to this one, C. We got to get better at figuring out writing the equation for an exponential function given a table. We'll work on that some today and tomorrow. Classify the following exponential function as growth or decay, and tell the growth or decay rate. Remember, growth or decay, if the b value, let's go back to black. If the b value is greater than 1, then that has to be growth. If the b value is in between 0 and 1, that has to be decay. Growth meaning it is going up, decay meaning it is going down. So all I have to do is look at the b value. Well, that number right there is greater than 1, so this has to be growth, which means it cannot be decay. Then it says, well, what is the decay rate? And if you go back to your notes and look at the formula for decay, or sorry, growth, we're doing growth, we know that I have a starting amount or initial amount, which is A, and then where my base is, to make it growth, I'm doing 1 plus whatever the rate is, right? And then raising that to a power. And this rate is listed in a percentage. We turn it into a decimal. Well, if what's in those parentheses right there is 1.07, then the rate is 0.07. If I turn that into a percentage, I just move the decimal 2 places to the right. This is the same thing as 7%. So my equation is growth. My rate is 7%. 107% would be a whole lot more than that. Sweet. Peachy Cinemas, number 4, 62%, not great. Peachy Cinemas uses the following function. F of x is equal to 4x minus 100 to determine their total profit. F of x, which is their total profit. Everybody good? F of x is their total profit for x customers that buy tickets to a show. So x is just the number of customers that buys tickets to a show. What is an appropriate domain for this function? And again, we're talking about domain, and domain is inputs, right? What are the possible input values? Appropriate means given the context, and input values are usually X values. So we're talking about number of customers that can buy tickets to a show. Can't have a half of a customer. So it can't be all real numbers because, well, one, all real numbers is negative infinity to infinity, and that includes all the decimals in between. Well, you can't have negative customers buying tickets to a show. Any numbers that are greater than 25, like, are you saying that only 25 people have to buy tickets to a show and 24 people can't? That doesn't make any sense. If you say X is equal to 4, that means only 4 people are allowed to buy tickets to a show. So the only one that makes any sense is whole numbers. And the reason that is because you can't have half a person. So one person could buy a ticket, two person can buy a ticket, 3, 4, 5, 6, all the way really up to infinity, even though probably is less than that because of the number of people they could fit in the show. Number 5, 92%. Good job. Find the equation of the exponential function using the table below. Sweet. Same thing here. Since it's an exponential function, that means we're multiplying each time. That means I'm trying to figure out what I'm multiplying by to get from one number to the next. That makes it just like a geometric sequence, which means you can take the second term and divide by the one before it. You can take the third term and divide by the second term. You can take the fourth term, which is 2.5, and divide by the third term, and so on and so forth, as long as your terms are only going up by 1. Meaning your X values are all increasing by 1, and they are. And when you type those all in the calculator, I'm not going to do them all. It should be obvious this time. 10 divided by 20 is again 1/2. So your base is again 1/2, and that rules out this one right here because the base is 2. That would be growth, and we've got decay. It rules out this one right here because that X is not even in the exponent. That means that's a linear function. So now I just have to decide, well, what's the base here? Is it the 1/2 or is it 20? If you look carefully, we always list our base inside parentheses, so the X applies, or the exponent applies to the base before we multiply by the A value. So the base here in this one is 20, which means it's going up, and the only possible one that it could be is the one right there, where the base is 1/2. They just wrote it as a decimal, and that's fine. You should also notice that the initial value here, since there's no horizontal movement or no vertical movement, is 20. So my equation should look just like that. All right, 5 down, 5 to go. Which of the following would represent the zero root for the function graph below? Zero, root, solution, or more importantly, x-intercept. And to find the x-intercept, you can either look at a graph or you can set y equal to 0 if you had an equation. They don't have an equation here. They just gave me a line, and solutions are where the graph crosses the x-axis, and that should have been super easy. I'm not sure why we got 62% on that one. Remember, zeros, roots, solutions, they're all x-intercepts. Set y equals 0 and figure out where the line is crossing the x-axis. It should be 3, 0. All right. Number 7, 85%, not too bad. Find the equation of the exponential function using the table below. Again, we should be getting good at this. Exponential means multiply every time. Oh my goodness, multiply by 1/2. Oh my goodness, multiply by 1/2. Oh my goodness, multiply by 1/2. Y'all should be seeing this now. It looks like 2/4 or 1/2 or 1/2 over 1 or 1/4 over 1/2. All those things give me a base of 1/2. So in my parentheses, I should have 1/2 with my x up in the exponent. Since it's an exponential equation, I should know that the initial value here is 4. So that initial value goes in front of that. That means that this one is no good right here because 1, we haven't talked about negative bases, and 2, that's not between 0 and 1. This one is no good right here because the base is 4, not the starting amount. That means that's growth. This one in here's got a 2 in it. I'm not sure where that 2 is coming from, but that means that it's growth. And this is not growth. It is going down clearly. So the only one that's left is that one, which is the exact same form as that. All right. 92% on this one's good. Gasoline costs $2.50 per gallon. That should be pretty obvious. That is a constant rate of change. Constant rate of change, the same thing as slope. So we're talking about a linear Linear understanding here, that's $250 $2.50 per gallon that you buy. So we're going to say X is gallons. You have $20 in your pocket. Write an inequality to express the number of gallons X you could put in your car. So I've got to equate how many gallons I can put in my car at that price, given I've got $20 in my pocket. Now, you could try to make these two things equal, but they want an inequality. So the question is, can you spend more than 20? This over here is what you're spending. This over here is what you have. So when you put gallons in your car, you better make sure that this number that you have to pay is hopefully less than that number. So we immediately need to say it needs to be less than. Now, the better question is, could it be equal to? If you have $20 in your pocket, can you go to the gas station and buy gas with all $20 of it? And the answer is yes. So you should be able to write this as $2.50 times X has to be less than or equal to 20. All right, and you'll see that answer is, these have them all on the same side. You could probably get that done by just subtracting, but you should notice here the 20 is with the X, and X is representing number of gallons, so neither of those are correct, and the one that matches our equation is C. Good, 92% was good. Which of the following functions would represent exponential growth? We know that all of our exponential growth formulas should be A times B raised to the x power, where B is greater than 1. I gave you an exponential growth formula to make sure that it is greater than 1. It looks like A is your initial value, and we do 1 plus the rate so that it's greater than 1. So all you got to do is make sure that your base is greater than 1. Look, here's the base. It's 1/3. That is decay. Here's the base. That's 5/3. 5/3 in a calculator, if you punch it in and try to figure it out, it would be 1.6 repeated. Is that greater than 1? Yes, it's growth. Here is the base. 0.2. 0.2 is between 0 and 1. That means this is decay. And this doesn't even have a base. That is y equals mx plus b, which is slope form. It's not even exponential. So your answer here should have also been C. Last but not least, we did really well on this one. What would be the growth or decay rate for the following function? Well, growth and decay, the rate has to do with the base. And remember, if it was growth, my base would be 1 plus my rate. And if it, see, this is growth. If it was decay, my base would be 1 minus my rate. This one right here gives me a base that's greater than 1. This one right here gives me a base between 0 and 1. So all I got to do is figure out what number. So my base here is 0.7. That obviously is not greater than 1, so we're not dealing with growth. I just have to figure out what number I can subtract from 1 to get 0.7. If you wanted to write it as an equation, you could do something like, hey, 1 minus r equals 0.7. Wow, that's pretty easy. To solve this, you would just do some simple algebra, subtract 1 from both sides. That gives you negative r is equal to negative 0.3. Then divide by negative 1 on both sides, and your rate better be 0.3. Turn that into a percentage, means take the decimal place and move it 2 places to the right, fill in the empty spot, and this thing is not only decay, it is by a rate of 30%, and the answer to that one is D. All right, you guys did pretty decent on this. Was hoping you guys win again, but we need to make sure we study and prepare for the next one. So move on to the next assignment, and I will see you guys on Monday.